All right, guys, so let's take a look at the Practice A worksheet on geometric sequences and series. If you look at the first couple problems, they're pretty straightforward until you get to numbers 20 and 21. You're writing a rule for the nth term if you're given two terms in the sequence. So set these up as a system of linear equations, substitute, and find your A1 and your R. Okay, once we get down to finding the sum, seems like there's a little bit of confusion with this. You want to use the partial sum equation, which states S of n is equal to A1, numerator is going to be 1 minus your common ratio raised to the n, over 1 minus the common ratio. Okay, so I know my n is 5. I know the A1 is 2. And the common ratio is 4. So let's plug everything in. I'm just going to write equals. A1 is 2. Then I have 1 minus 4 raised to the 5th power over 1 minus 4. Okay, so if I'm using my phone as a calculator right now, I should be able to solve this. You guys obviously are going to be using a better calculator. So if I take 4 first and I raise it to the 5th power, I'll get 1,024. So 1 minus 1,024 will give me a negative 1,023. Bottom is going to be negative 3. So make these obviously both positive. You'll get 341. And remember, you still have to multiply the 2, right? So 2 times 341, don't forget, which should give you 682 as a final answer. All right. Now, so that's number 23. There's a little confusion as to what the n was actually referring to and if we had to solve. So you should get 682 for your partial sum. If I'm looking at number 25, same exact thing. I want to use the partial sum formula. Now it's saying find the sum of the first n terms of the geometric series. And then for part B, is the first time we looked at this, you're actually given the partial sum, and then you have to kind of work backwards. So let's do the exact same thing we did for 23, and we'll do it for 25. The only thing we're going to change is n is going to be 10, right? And our A1 and our common ratio is going to be different. So if I'm plugging this in, the A1 is going to be my first term. So partial sum is going to give me 1 times, and then I have to find my common ratio. In number 23, it was given to you, but now you have to figure it out. Common ratio is obviously the pattern, the difference here. Not necessarily the difference, I'm sorry, the pattern. It's going up by times 4. So my common ratio is 4. All right, and then the n in this case is going to be 10. So very similar to the last problem, only we had a different A1. And in this case, we had a different n. So if I'm going to take 4 raised to the 10th power, right, it's a pretty big number, and then subtract 1, all right, divided by negative 3, and I will get 3,000 for number 25, part A, 349,000, sorry, 525. All right, that's what I'm most concerned with. You should definitely get the A. Now, if you're looking at the B, this is for anyone that really wants a challenge. They're then going to tell you that the sum is 21,845. So now you're just going to have to work backward. You have to find, it says find n for the given sum. So in B, you don't know what the n is. We're going to work backwards. So I'm just going to write it over here because I have more room. The S of n is 21,845. Now you can plug everything else in. You could write a 1 here if you want to. And then this is going to be 1 minus 4. We don't know what the n is for this one. And then 1 minus 4 again. So now we're going to solve for n. And this is a challenge because you're going to have to use guess and check unless you know logarithms and logs and stuff like that. That's going to be like high school level math. But in order for me to isolate the n, I'm going to multiply by the denominator. So 1 minus 4. And I can't write it, so let me just move it over here. See if I could squeeze it in. So top and bottom, 1 minus 4. All right, so just to show you, these will cancel. You have to multiply the left-hand side. You could do 1 minus 4, or you can do just negative 3. The same exact thing, it doesn't matter. It's the same value. So I just did that just to show you that they would cancel out. You can multiply it by negative 3. You'll get some crazy answer. Let me see if I can do this really quickly. My calculator. Negative 3 times 21,845. I'll get negative 65,535. Now here's where it gets complicated. You have 1 minus 4 raised to the n. We want to solve for n here. It's probably the first time we ever did it. What I'm going to do is I'm actually going to change the order. Instead of writing 1 minus 4n, right? Actually, you know what? I could leave that. It doesn't really matter. This is a positive one. I'm just going to subtract 1 on both sides, right? And I will get something like, let me just double check this. I'm doing this right, okay? Negative 65,536 is equal to negative 4 raised to the n power. Now you're basically saying 4 times what number, what power will give you 65,536. Now that's going to be, if I raise this, I believe to the 8th power. Yeah. All right, so this is going to be to the 8th power. N is going to be 8. All right. Now, again, I don't expect you guys to know that, but that's for anybody that wants a challenge. Let's do another sum problem. All right, let's see. I think 27, 28, or 29. All right, let's look at number 27. I know we had a lot of questions for this one. Just to be clear, on the PowerPoint, it didn't tell you really the information about this symbol. I mean, it means the sum of, but basically this I is equal to 1 is your starting point, and the 15 is like your end point. Okay, so like how many numbers we're going to have in the series. So what you're essentially doing here is you're setting up the partial sum formula, but the only difference is n equals 15 here. And that's the part of the information that they didn't tell us. So if you look at number 29, n is going to be 11, and that 0 doesn't really affect it. It's just the starting point, okay? So if I know this information, we're going to, again, do the exact same thing we did before. Partial sum is, I'll write it down here, A1, 1 minus r to the n over 1 minus r, and plug in what you have. So A1, you just have to be able to read this. A1 is 4. Your common ratio is 1/2, right? And then your exponent here, your r to the n, that's going to be 15. All right, so I know what you guys are thinking, like, 1/2 raised to the 15th power is a really a small number, but what you're going to do is I'm going to just change 1/2 into a decimal. Makes it a little bit easier. If I round that to, if I raise that to the 15th power, I'll get a really small number. But if I take 1 and I subtract it, I'll get close to close to 0.99 or something like that. All right, so whatever that value is, I'm then going to divide it by the denominator, which is 0.5, and I'll get a number that's close to 2. So this is what I'll get. I'll get 4 times everything in here is going to be, let's get this out of the way for a second. Is going to be roughly 2, but I'm going to be as accurate as possible. Even if I round it up, it would be 2. I'm not going to round up. I'm just going to leave it like this for sake of the lesson. 4 times 1.99, and then you could say about or approximately 8. So 4 times 2 is going to be approximately 8.00 or 8. That's going to be your final answer. If you want to go ahead and do number 29, you should get very similar to this. You're going to get approximately, after doing it, same exact thing, approximately 12 after rounding. All right, so if you guys have any questions, you can leave me a comment in the chat. We're definitely going to talk about this in class again, so I think we're just done for the review.